I'm Lauren.
And I'm Julia.
And today we are going to show you how to measure a tree with shadows.
It's a form of something called indirect measurement.
This is a tree from my backyard.
First, we took a few measurements, such as the length of the tree's shadow.
Then my height and the length of my shadow.
And finally, my height and the length of my shadow.
Using these measurements, this is how we found the height of the tree indirectly.
This is how we did it.
First, we used a tree in my backyard around 1 o'clock. Then measured the shadow of it that was created by the sun.
And I measured Lauren's shadow and she measured mine.
To find x, which is the height of the tree, we created triangles as our diagrams. For the triangle of the tree, the height is unknown, so that is labeled x. In the base of the triangle is the length of its shadow, which is 597 centimeters.
Then, for the triangles of us, the height is our own heights from head to toe. The base is the length of our shadows that we measured.
My height is 164 centimeters over my shadow length, which is 107 centimeters.
My height is 148 centimeters, and my shadow length was 95 centimeters.
With these measurements set up in diagrams, it creates triangles.
Similar triangles, to be exact. To prove that they are similar, we need to find at least two angles that our triangles have in common.
The first angle they have in common was a right angle.
We know the triangles both have right angles because we were standing up straight, and I'm pretty sure the tree was too. Because the ground is flat as well, our shadows and heights created a perpendicular angle,
which is a right angle.
The next angle we know that they have in common is because of the sun.
The length of our shadows depend on the angle the sun is above us. When the sunlight hits us and we cast a shadow, it is doing so at a certain angle from the sky. The same sunlight that is creating a shadow under Julia and I is hitting the tree as well,
making the shadows proportionate to each other.
The angle from the top of our heads and the top of my tree to the end of our shadows would be the same because of this.
Through the similar triangles theorem, which says that you only need two angles in common for a triangle to be similar, we know that the third angle does not matter.
Now for the complicated part.
It's not that complicated. It's actually quite simple. To find the height of the tree, all you have to do is use proportions.
That's right, because they are similar triangles, so that means we can take the height and the base to create a proportion, then solve for x to get the height.
For me, we first took the height of the tree, which is unknown, or x, and put it over my height, which is 148 centimeters. Then we put the length of the tree's shadow, or 597 centimeters, over the length of my shadow, 95 centimeters. After cross-multiplying, getting 95x equals 88,356, we solved for x to get the height of the tree as 930 centimeters.
Then we created the portions the same exact way we did Julia's, and we got x equals 915.02 centimeters for the height of the tree. But why are our answers different?
Well, because we could have ran into some possible errors.
Maybe we didn't measure the shadows accurately enough.
Or maybe we were far enough away that the sun hit us at different times.
Hopefully you learned something, and thanks for watching.
Bye everyone!